Hey guys, welcome back. In this video, we're going to take a look at EIGRP add path. Now, there's a few things I want to mention here when you're configuring this and playing with it. First of all, the whole idea here is that if we have a hub and spoke environment, such as a DMVPN, so let me write that down here, DMVPN, right? The whole idea is that in a either a multi-hub or a single hub environment, point is that if we have multiple hops to reach a specific destination, so in our case here, if router 4 is a spoke and router 5 is a spoke, router 1 is the hub, has two equal cost paths. Well, look at that, it's a heart, it's like Valentine's Day. He has a equal cost path going to 10.24.35.0. And so now if we add router 6 as a spoke, right, what's going to happen is that in the rib, router 6 is only going to see one or the other. In other words, router 1 as the hub is only going to advertise out one of these as a valid next hop to that particular subnet. What AddPath allows us to do is have up to 4, so let's say maximum of 4 best hops advertised in the rib on that particular spoke. So if router 1 had 4 spokes that could all reach the same subnet, router 4 would advertise out to the other spokes, hey, there are essentially 4 different next hops you can go to in order to reach that particular prefix. Okay, now, based on Cisco's documentation, they do recommend that you disable next hop self. I think there's a hyphen in there, but I'm not sure. I always use the tab key. We'll just put it in there, and if I'm wrong, it is what it is. So they do recommend that you disable next hop self on the tunnel interface, so essentially here, when you configure this feature. Now, in phase 3, you have what's called a next hop override. So I've seen people not disable it because they have the next hop override. I generally just go ahead and disable it anyway because it's part of Cisco's documentation. I know that it may not always be 100% correct, but when I dial 1-800-HELP-ME-NOW, I don't like people to read back documentation to me. I like to be able to say, yep, no, followed your exact document, so have at it. Now, there are a couple of key points here that I want you guys to remember, and that's the fact that this is an iOS XE feature, and so you're not going to be able to run this in regular iOS. So for example, for those of you guys running this in a simulator, this might mean you have to run this on a 1000V. The other piece to this is that this has to be run in named mode. Now you'll see here that I already have an adjacency up and running. I actually have this guy configured in classic mode, and the reason is because I want to use the opportunity to show you kind of the order of how I do this in a particular configuration. If I'm going to walk into an environment and I walk into something where I'm going to go ahead and deploy EIGRP between these spokes and this hub, and obviously maybe they're already running classic mode on this device because maybe they have some LAN segments in here, and I'm going to go ahead and add this. I want to show you essentially how I walk into this particular environment and how I might manipulate it. Okay, so the first thing here is I'm going to go ahead and I'm going to enter my tunnel interface, and the first thing I'm going to do is say no IP split horizon EIGRP, and then whatever my autonomous system number is, which, by the way, if I forgot to jot it down here, it's going to be autonomous system 1. Now once we get this up and going, what we're going to do is we're going to advertise this subnet here in from both of the spokes R4 and R5, and we'll see that router 6 is only going to essentially have one of them in his rib by default. So next thing I'm going to do is say no, and I'm going to say next hop self, no IP, next hop self. I always do that. EIGRP1. So let's say do show run interface tunnel 1. Now what's going to happen here is that, like I said, we're currently running classic mode in EIGRP. So what's going to happen here is that the minute we go ahead and convert classic mode to named mode, it's almost less typing for me because EIGRP will automatically convert these commands here under the interface into named mode for me. So let's say do show run section router EIGRP. There's my classic mode EIGRP configuration, but again, I need it to be named mode. So what I'm going to do is enter the process. I'm going to say EIGRP upgrade CLI, and you know what? I make this mistake a bazillion times. You would be surprised how many times I make this mistake. I always hit enter here and it says incomplete command, and I have to up arrow, and I forget that what it wants is the actual name. Most of us are used to BGP, where we would come in and say, upgrade CLI, yes, and it would upgrade BGP. But since we're going from classic to named mode, we need to actually give this guy the name that we want. So we'll just say DMVPN. It's going to say, are you sure you want to do this? Yes. It's going to pop up and say, hey, now your conversion is complete. So let's say do show run section router EIGRP. And what you'll see is that it automatically created my address family tunnel interface, and it automatically put in the no next hop self and the no split horizon. So let's go over, let's say on R6, let's say show IP EIGRP neighbors. Let's validate. We still have a neighbor. That's good. Let's say show IP route EIGRP. So we have router 4 and router 5's loopbacks. Router 1 should have all of them. So let's say do show IP route EIGRP. We have router 4's loopbacks, router 5's loopbacks, and router 6 loopbacks. So this is a good deal. On router 4, 5, and 6, guys, if you've watched any of my previous videos, I use the same topology throughout almost all of my videos. Reason being is that you guys, as you watch, can get used to how I have it set up. Each individual router has 3 loopbacks. The third octet matches the router ID, and then these are all /32s. And this fourth octet matches the loopback, I want to say number. So loopback 1, loopback 2, loopback 3, etc. So let's go on to router 4 here, and let's go ahead and turn on EIGRP for this LAN segment. So router EIGRP1, network 10.24.35.0, and we'll go ahead and say /24. Let's go on to router 5, do the same thing, network 10.24.35.0, 0.0.0 or .255. And in theory, what we should see when we head over to router 1, if I say do show IP route EIGRP, we should now see that router 1 sees an equal cost path over towards this network, and he can either go to router 4 or router 5. But let's check router 6. What we should see in router 6, in theory, is that router 6 is only going to have one of these in his rib. Let's say show IP route EIGRP, and there is our prefix, but I only have router 4. And so this, again, is where the issue might be, is that now my next hop is essentially being router 4. What am I going to do with this? What if I want to send or need to send or want to have, you know, both of those paths? And don't forget, it's Ceph that's actually going to do the load balancing. So you might find that Ceph still sends this to router 4, even though we have dual entries in the rib. But the point is that what if I need to have these for quicker failover or whatever it may be? I need to have both of these routes in my rib. This is where the add path comes in. So let's say do show run section router EIGRP so we can tweet a little bit. Cheat. I was just watching the Saturday Night Live skit of Donald Trump, and so I got tweet on the brain because he kept talking about tweets. So I'm going to say router EIGRP DMVPN, address family, and I need to go into my address family interface for tunnel 1. Okay, so once I'm under this interface, I can use the command add paths, and I can use up to 4. So I can't unfortunately use a maximum of I can't use 5. I can only use a max of 4. In this case, I don't need 4. I just need 2. What you're going to see is the EIGRP resync. Now, it is also recommended that you do not use the variance command in addition to add paths, because the variance command can mess with the metrics and therefore cause more problems. So it's recommended that you don't use the variance command in addition to add paths in this scenario. So once I have the add paths, you can see that my routing table show IP route EIGRP did not change on router 1. We already had both of these paths coming in over our DMVPN tunnel. However, if I go and check router 6, you can see that I had a graceful restart. And now here was the individual entry. Let's go ahead and let's actually check our routing table. Now you can see in our rib, it's a duplicate of what we see in router 1. So here's the metrics. Obviously the metrics are different, but you can see we can either go to spoke 5 or spoke 4, and router 6 has the same information in his routing table, either spoke 5 or spoke 4. So this is how the add path command can help us to essentially add multiple entries in our routing table from the hub. If we have multiple hops, multiple best hops from the hub will essentially report back to the spokes, hey, there's more than one way for you to get to this network. You don't always have to go through router 5 or router 4. You can go to either one and essentially get to the same LAN segment.